Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 13, Statements of Order in the Real World. So up until now we must have been in a fake world. Now we're in a real world. Classwork, opening exercise. A radio disc jockey reports that the temperature outside his studio has changed 10 degrees since he came on the air this morning. Discuss with your group what listeners can conclude from this report. Okay, so in class, this was a group activity, and I'll bring the results in. Okay, here's what we can conclude. The report is not specific enough to be conclusive, because 10 degrees of change could mean an increase or a decrease in temperature. A listener might assume the report says an increase in temperature, however, the word changed is not specific enough to conclude a positive or negative change. The other thing that they might have said was we didn't know what either temperature was, so it could have been 50 and now it's 60, or it could have been 60 and now it's 70, and so forth. Okay, so here's example one. Ordering numbers in the real world. A $25 credit and a $25 charge appear similar, yet they are very different. Describe what is similar about the two transactions. Okay, so similarities would be you're using the same number, 25. The absolute value, the distance from 0 for positive 25 and negative 25 is still 25. Their differences would be their sign, one's positive, one's negative. Okay, so let me just bring in the detailed information on this, and you can write it down or pause. Okay, so here we go. The transactions look similar because they are described using the same number. Both transactions have the same magnitude or absolute value, and therefore result in some sort of change of $25 to an account balance. Now it says, how do these two transactions differ? Okay, the credit would cause an increase to an account balance, and therefore should be represented by 25, while the charge would instead decrease the account balance and could be represented by negative 50. The two transactions represent changes that are opposites. Okay, so here's exercise 1. Scientists are studying temperatures and weather patterns in the northern hemisphere. They record temperatures in degrees Celsius. So let me stop right there, because in geometry we talk about this word right here. Okay, hemisphere. Well, a sphere is a ball. Okay, like the globe, Earth. Okay, it's a three-dimensional ball. A hemisphere, hemi meaning half, is the half of the sphere. So when we say northern hemisphere, we mean north of the equator. All right? So anyway, moving on. Represent each reported temperature using a rational number. Rational meaning ratio is the root of rational. Rational numbers are any numbers, positive or negative, that can be represented as a fraction. Order these rational numbers from least to greatest and explain why the rational numbers that you chose appropriately represent the given temperatures. So this says 8 below 0. Below 0 means it's negative, so I'm going to put negative 8. 12, temperature 12, that's positive, so it's 12 degrees. Negative 4 is below 0, it's negative. 13 below 0 is negative 13. 0 is 0. 2 above 0 is a positive 2. 6 below 0 is negative 6. And negative 5 degrees is just negative 5. Okay. Explain why the rational numbers that you chose appropriately represent the given temperatures. So the first thing I'm going to do is order them. It says that also. Order the rational numbers from least to greatest. Underline that in your book always whenever you're doing a problem. Underline what they're asking. Least to greatest. So what is the smallest number, which is the biggest negative? Negative 13. negative 13 is less than. And then I go look for the other largest negative, 5, 6, 8. Negative 8, comma, negative 6. So now I have less than negative 6. I don't need commas here. Negative 8, less than negative 6, less than negative 5, less than negative 4. So I dealt with all the negatives, and they are getting closer to 0. And then finally, negative 4 is less than 0. And now we're going to go on the positive side. So 0 is less than 2, and 2 is less than 12. Those would have been only positive values. Why did I put negative? Less than 12. Okay? So then it says explain. Okay? Don't ignore this word here. Explain why rational numbers that you chose appropriately represent the given temperatures. Okay? So the words below 0 refer to negative numbers because they are located below 0 on the number line. So that's why we chose these below zeros as negatives, and negative is less than 0, and positive are greater than 0. Okay, number 2. Jamie's bank account statement shows the transactions below. Represent each transaction as a rational number, describing how it changes Jamie's account balance. Then order the rational number from greatest to least. So I'm going to underline that, greatest to least. Then explain why the rational numbers you chose appropriately reflect the given transactions. So remember, a rational number is a number that can be represented as a decimal or a fraction. So I can write these as decimals. So a debit, remember, debiting means you're using money, you're spending money. If you use a debit card, you are spending money. So that's a negative change to your account. And if I purchase $12.20 worth of groceries and I swipe my debit card, okay, then it is going to take $12.20 out of my account. That's a debit minus. A credit is when people give you money. They put money in your account. That's going to be a positive 408. A charge of $1.50 means they're going to take $1.50 out of your account. A withdrawal of $20 is also taking 20 out of your account. It's like going to the ATM and getting cash. Okay. A positive $5.50 is positive. So I'm doing negatives in red, positives in green. There's another debit of $3.95. Might have rented a movie off of Amazon Prime. And then finally, a charge of $3. Okay, charge of $3. That is also positive. Okay. All right. So now it says to order these rational numbers from greatest to least. So if you use colored pencils and color code your positives one color and your negatives the other, they just pop out at you. Now I can just focus on the two green ones. And which one's bigger, 408 or 550? Okay, it just makes life so much easier. And instead of 550, I'm just going to put 5.5 because that's equivalent, and that is a rational number, which is greater than, simple changes from the last problem. 4.08 is greater than. And now I've got to look at my negatives. Now remember, smaller negatives are actually bigger. Bigger negatives are smaller. The further we get from 0, the bigger the number gets negatively. So I want the smaller numbers first in red, and 1.5 is the smallest. And I might as well stick with my colors, right? So back to red. Negative 1.5, and I just don't use the 0 here, is greater than. The next one is 3 and 3.95, so minus 3 is big, is greater than negative 3.95 is greater than negative 12.20 is greater than negative. Okay? Oops. 12.20 is greater than negative 20. Okay. There it is written as integers. Now the explanation. Okay, so here's a lengthy explanation of this. The words debit, charge, and withdrawal all describe transactions in which money is taken out of Jamie's account, decreasing its balance. These transactions are represented by negative numbers. The word credit and deposit describe transactions. Put money into Jamie's account, increasing its balance. These transactions are represented by positive numbers. Okay? So now this is the way of the question, so I'll just slide this up out of the way here. Okay, and number 3. During the summer, Madison monitors the water level at her parents' swimming pool to make sure it is not too far above or below normal. The table below shows the numbers she recorded in July and August to represent how the water levels compare to normal. Order the rational numbers from least to greatest, underline what they're asking for, and explain why the rational numbers appropriately reflect the given water levels. Okay, so for starters, I'm going to focus on the word above. That's positive. It's greater than what we want. Above. Okay. Above. Below. Okay? Below is negative. Below means the water level is lower than we want it to be, and that's not good for the pump if you're having air go through the pump, loses pressure, and the water doesn't circulate, get clean. Alright, so here we go. 1/2 inch above normal is a positive 1/2. 1/4 above normal is a positive 1/4. 1/8 above normal is a positive 1/8. 1/2 inch below normal is negative 1/2. 1 1/4 below is a negative 1/4, and a negative 3/8 below is negative, and 3/4 below is negative 3/4. Least to greatest. So the biggest negative number is negative 1. So negative 1, 1/4. Is less than 1/2, 3/8, 3/4. I'm going to do common denominators here so it's less confusing. 4 will go into 8, 2 will go into 8, so let's make this an 8. So it'll be negative 4/8. And this is okay. I need to multiply this by 2, so it's negative 6/8. So we have 6/8, 3/8, 4/8. The smallest is 6/8, which is 3/4. Okay, so that would be negative 3/4 is less than negative 4/8, or negative 1/2 is less than 3/8, which is negative 3/8. And then we get to the positives, and now we're going from least to greatest again. Let's do it in 8s. So 4 times 2 is 8, so it's 2/8. And to get 8 on this, we have to multiply 2 by 4, so it's 4/8. So we have 1/8, 2/8, 4/8. 1/8 is less than 2/8 is less than. Okay, and now I'll bring in the explanation. Okay, the measurements are taken in reference to normal levels, which is considered to be 0. The words above normal refer to positive numbers located above 0 on the vertical number line, and the words below normal refer to the negative numbers located below 0 on the vertical number line. Okay, so there's our answer to number 4. Changes in weather can be predicted by changes in the barometric pressure. Over several weeks, Stephanie recorded changes in barometric pressure seen on her barometer to compare local weather forecasts. Her observations are recorded in the table below. Use rational numbers to record the indicated changes in the pressure in the second row of the table. Order the rational numbers from least to greatest. Okay, so I'm going to focus on the words here. Rise, positive, rise, positive, rise, positive. Fall is negative. Decreased. The barometric pressure fell. Decreased. Okay, so we want to order least to greatest, so let's focus on red first. And this would be negative 0.21. This would be a negative 0.03. Negative 0.09. Negative 0.14. A rise is positive. That'd be 0.04 positive, 0.2, and 0. Okay, if you color code these, it makes it much easier to decipher. It's less to choose from while you're trying to figure this out. Okay, the bigger the number, the smaller it becomes when it's negative. So 3, 9, 14, 21. 21 is the largest, so negative, it is the smallest. And that is less than. 14 is next. It's less than 09. Whoops. I do not like when it erases more than I want it to, but that's because I write too quickly. Okay? It's less than negative 0.03. And now I'm going to focus on the positives. 0.1, 0.2, 0.04. Be careful. That's 4 100ths. That's 20 100ths. That's 10 100ths. 4, 10, 20. 0.04. 0.1. Why am I doing commas? Okay. So 2/10 is greater than 1/10. All right, there it is, in order from least to greatest. Now I'm going to bring in the explanation. Explain why the rational numbers are represented appropriately. Okay, the records that include the word rise refer to an increase and are therefore represented by positive numbers. The records that include the word fall refer to decreases and are therefore represented by negative numbers. Okay, next question, example 2. The captain of a fishing vessel is standing on the deck of it at a 23 feet above sea level. Okay, so he's standing on the deck 23 feet above the water level. He holds a rope tied to his fishing net that is below underwater at a depth of 38 feet. Draw a diagram using a number line. And then use absolute value to compare the lengths of rope in and out of water. Okay, I'm not even going to attempt to draw this in here, so I'll do it elsewhere and bring it in. So first, let's put some thought into this. The captain is above the water, and the fishing net is below the water surface. Using the water level as a reference point 0, I can draw a diagram using vertical number line. The captain is 23 feet above 0, and the fishing net is negative 38 feet, or 38 feet below 0. Okay, using absolute value, I can then conclude that since the captain is 23 feet above sea level, the absolute value of 23 is 23, and the fishing net is negative 38 feet, or 38 feet below the water, and that is a distance of 38 feet from the surface underneath. So there's more rope underwater than above. Okay, so here's a diagram that represents this. Okay, so we have a boat right here, and here is the captain standing on the boat, and he is 23 feet above the water. The x-axis is the water, so he's at positive 23 right here. So the rope is right here, so that's a length of 23. And then the net is way down here at negative 38. So this length is 38 feet. 38 feet, 23 feet. Okay, so there's our diagram to explain this. Okay, so if we take that 38 rope under the water minus the 23 feet rope that's above the water, then we see that the length of the rope below the water surface is 15 feet longer than the rope above the water. Okay, so we just found out the difference as well. Okay. Example 3. A recent television commercial asks viewers, do you have over $10,000 in credit card debt? What type of numbers are associated with the word debt? Why? Okay, so the numbers associated with the word debt are minus or negative. If you owe somebody something, it's not a good thing. It's a negative thing. It's not positive. So we use the minus. So our value, our money, is negative 10,000. Okay. Write a number that represents value from the television commercial, and there it is, negative 10,000. Give one example of over $10,000 credit card debt. Okay. Well, about negative 11,000. If I owe 11,000, that's more than 10. Then write a rational number that represents your example. Okay. So one example of over $10,000 in credit card debt would be $11,000 in credit card debt. How do the debts compare? Well, negative 10,000 is less than the negative $11,000 debt. Okay. That's the end of lesson 13. Your problem set.